All right, I'm going to do this both with the I's and with, just the normal letters. Possible genotype for type B blood would be like this, if you have both the B allele, right? Or if you're B allele and then O. That's the same thing as saying BB or BO, okay? There's only one way to have type O blood, right? And AB, there's only one way to, there's only one way to have it. Try to put the A first. Those are lowercase i's right here. You talking about these right here? Yeah. Those are my lowercase i's. If you're blood type O and you marry blood type AB, so I'm just gonna blood type O. There's only one way to be O. AB. You just draw a Punnett square. Right. Type O is a phenotype. You still have to write it out as a genotype. So with the genotype, there's only one way. And so when you combine the gametes to form the zygotes, the offspring, you have a type A. That's the phenotype of that offspring. Type A. Type B. Type B. So list the possible blood types. What are the possible? Well, there's only two possible blood types. The offspring can either be type A, which is 50-50, or type B. They're not really asking for any ratios. They just want to know what the possible blood types are. In the 1950s, a young woman sued Charlie Chaplin. He was the old silent film actor, for parental support of his illegitimate child. Charlie Chaplin was AB. The mother was A. Her son was type O. Okay, so the mother could have been A because she's homozygous dominant for A or heterozygous for A. So I'll do the two possible Punnett squares with Charlie Chaplin. There's only one genotype for Charlie Chaplin because he's AB. Now, mother could have been like that, or mother could have been like this. Now, obviously, most of you guys can just rule this out off the top, because how in the world are we going to get a child with O if nobody here has an O allele? But we can at least try this way. Type A blood type, AB blood type, type A blood type, and type B blood type. In no way can Charlie Chaplin and this mother with type A blood produce a child with type O blood. And in order for that to happen, you would need both parents to carry the O allele. Yeah, he was not the father. You are not the father. So the judge ruled in favor. Was the judge correct? No, because look, here's your evidence. Look at both Punnett squares. Both Punnett squares, there's no way. Now, let's say we got this newborn baby was type O. So the baby is O. Right? Now we have the Mr. and Mrs. Brown, where Mrs. Brown is type B and Mr. Brown is type AB. Now, at the very least, Mrs. Brown has to have at least have an O, right? Because the baby's O. Some sort of mix-up at the hospital. Mr. and Mrs. Smith, however, you have Mrs. Smith was type B, so we can just assume you got to have at least an O. And Mr. Smith was also B. Let's assume that he has an O as well, because we have to have a baby with an O. You can see that, once again, guys, since Mr. Brown is AB, it's just like the Charlie Chaplin. Can't produce a child that is O. These are both type A. That's type AB. That's type A. I'm sorry, this is both type B. Now, Mr. and Mrs. Smith, since they're both type B, you can definitely have it right here where the baby is type O. That will produce a baby who's type O, type B, and type B here. To which do the baby belong? The Smiths. Bam. Okay, so we'll use our eyes here, guys. A man with blood type A, right, marries a woman with type A, B. That's the same thing as going like this. What are the genotypic and phenotypic ratios? Well, it's pretty simple. There's a genotype. There's a genotype, right? The phenotype is that person is going to be type A. That person is going to be type A. There's a genotype. There's a genotype. They're going to be type AB, type AB. The genotypic ratios, genotypic ratio, you know, AA, it's 2 out of 4, 50%. The phenotypic ratios, that's what that abbreviates for. Type A, there was 2 out of 4, 50%. Type AB. You could have also written, sorry, forgot my other genotype here. You could have also written this at like this, right? Those are another way to write the genotypes. A man with type B blood marries a woman with type A. Their firstborn child has O. Because the only way to be O is with 2 O's, you know that each person has to have an O. So obviously, if you're type B, you have to be BO, and type A, you have to be AO. So the genotypes of the father and mother are BO and AO. You can also write that like this. Oops, not O, but it's a lowercase I. Another way to write it. What is the genotype and phenotype of the baby? Well, there's only one way to be the baby. Type O. They already told you that the baby was type O. Another way to write that is 2 lowercase i's. Last question. Man with type O marries a woman with type A, B, right? What are the predicted genotypic and phenotypic ratios of the babies? Genotype, phenotype, genotype, phenotype, genotype, phenotype. Just so happens in this case that all the genotypic and phenotypic ratios are the same. So the genotypic ratio, you got AO, there's 2 out of 4, 50%. BO, 2 out of 4, 50%. That's a ratio of 2 to 2 or 1 to 1. Type A, same thing. 2 out of 4, 50%. So that's and then type B, same thing. You're going to have a 2 to 2 ratio, or that can be reduced to 1 to 1.